Student, today in this video I am going to explain you how you can use the meter bridge to find out the unknown resistance of a given wire. So you can see the principle on which this instrument, the working of this instrument is based. So here's the principle indicated over here in this sheet, Wheatstone bridge. So through this figure I can show you how you can arrange the different component of this device. So see here the two terminals A and B, you can use these two terminals. Here's the A and here's the B. You can compare your apparatus with this diagram. Now in between, so here's the resistance box. You can see in between these two terminals resistance box is connected, and after that resistance box, from this terminal a galvanometer is attached. So from this terminal along with a resistance box, just to minimize the current passing for the galvanometer, here's also a resistance box, and a galvanometer with a jockey is attached over here. Now after the galvanometer you can see a unknown resistance, a wire of unknown resistance. So here you can see here a wire of unknown resistance, and we have to find out the resistance value of this wire. So now the two terminals A and B must be connected with the battery or the cell. So you can see here, here's a cell, here's a key to interrupt the current in the circuit. Now here in Slidewire meter bridge you can see a special wire is used. So here's the wire of 1 meter length, and this wire is made up of constantan or manganese. Please listen, this wire is made up of constantan or manganese. What is the special property of this wire? Along with the change of the temperature, its resistance does not changes. It's very important to know this, that along with the change of temperature, its resistance does not changes. So see here, how can we perform this experiment? So after this whole connection, first of all we should check that connection, whether connection is correct or not. Is there any problem? So it can be find out. First of all you should hold the jockey and should keep at one terminal of this wire. See here. Now you can see the deflection in the galvanometer. Please see here. Here you can see, manage the camera over here. You can see the deflection in the galvanometer. At this terminal deflection is in this side. Now see here, what will happen if you are keeping your jockey over here? Now the deflection get reversed. Please see here in the galvanometer. So deflection in the galvanometer get reversed. This one is showing that there is the correct way of connection. If this one is not happening, that is galvanometer is not showing the two directional deflection, then only one thing will be there. Either two things will be there, either your connection is wrong or the wires are loosely connected. So see, now I am going to perform the experiment. First of all we should keep our jockey over here and should slide this jockey over the length of the wire. You can see here, along with the sliding, the reading of galvanometer is changing. Here in the galvanometer, please, in the galvanometer you can see here that reading is continuously changing. So you should move this jockey up to that point for which the deflection in the galvanometer becomes 0. So see here, now deflection in the galvanometer is 0. So you can write this length, resistance of this length, it is indicated by L. This length is indicated by L. So resistance of this length will be taken as P, and the remaining length, that is 100 minus L, it will contain the resistance of Q. L having the resistance P and 100 minus L remaining part of the length having the resistance Q. So now you can write the reading from here. I have managed here unknown resistance. So first of all, serial number 1. I have taken resistance of 2 ohm from the resistance box. So it's the, you can see here, value of known resistance. So from the resistance box it is 2 ohm. Now balancing length L, it is taken as 33.3, and after that 100 minus L, you can also take the decreasing reading. Actually you should write the reading from this terminal, and after that by exchanging them means this should be at this terminal and this wire should be at this terminal. And when you will perform the experiment, you will note the reading of L from this terminal. You can see the 2 directional readings are there. So now reading will start from here. So this one is known as the decreasing reading. So you can see increasing reading in the first part 33.3, decreasing reading 33.5, now taking the mean 33.4, and 100 minus L is 66.6. So from the formula S is equal to the R 100 minus L divided by L, we got the resistance of unknown wire is equal to the 3.99 ohm, that is very close to the 4 ohm. So after that you can change the value of resistance from the resistance box. That is, if there is 2, you can also pluck out one more key. So 2 and 1, now the resistance of resistance box becomes 3 ohm. Again you will keep your jockey at that terminal and will slide. You are sliding the jockey, that's why it is known as the slide wire meter bridge. So by sliding you can get another value of L, the remaining length 100 minus L, resistance of L length is again considered as P, resistance of 100 minus L is again considered as Q, and by using the same formula, that is S, resistance of this wire is equal to the R, known resistance of resistance box in bracket 100 minus L divided by L. So you will again calculate the value of, same value of resistance of this wire, and you will again get the same value, that is very close to the 4 ohm. So in this way you can take different reading by changing the resistance of resistance box, but main thing is that for all these values there will be the same value of unknown resistance of resistance box. There may be slight variation. So after that you have to take the mean value of resistance, and that will be very close reading of unknown resistance of resistance box. So in this way you can perform this experiment. It's very simple and it is very easy. It is very important for examination point of view also. Thank you.